Thank you. Hello, everyone. Just going to restart my timer here. My name is Menno Kortekaas from CircleB, and CircleB is a solution provider based here in Amsterdam, and we focus on the European region. And I wanted to present to you today how you could get started in designing your own open compute-based solution. And we promote the OCPREG18, so that's what we use as our basis for our solution designs. CircleB provides these solutions based on rack and power, server, storage, and networking components, and then we offer our services on top of that. So for who are these type of solutions? We think that for you the size matters. You need like at least 10 to 20 racks as a goal to reach the benefits that OCP offers, like efficiency, the toolless design, the openness, and the impact. You also need to change your mindset a little bit. You need to start thinking at a rack scale. We say often that the rack is kind of like a chassis, because you have all those the modules that I mentioned before. They're all inside of that rack, and they all need each other. You need to start at a rack level. Then you need to think modular. So we have separated the storage from the server, for example. So that's one of the modules, but also inside of a storage unit, a smaller module would be like the controller board. So you could choose if you want to have a PCIe controller or a SAS controller. And then you need to think in fewer components. You need to think find commonalities and look to build a solution out of as few components as possible. Also commodity computing, that's kind of you use commodity hardware and not like specific vendor components, but try to look for commodity. Then we look for operational efficiency, because that's where you get like most of the benefit. And one way is by doing that is minimize the human interaction. So why should you partner with a solution provider? We offer a single point of contact and local support. We do validate designs. So OCP, it offers a lot of specifications, but it's not really a standard. So some things that from like a specification, it looks like it'll fit, but it might not fit, or it might not work together. So we offer those validated designs. So we make sure, like before we deliver it, that it's all validated and all compatible. We also can help you to convert from your traditional deployment to OCP, and all that translates into a time and resource saver. So you should also consider the workload, what you are running on your servers. In a basic operating system level, we support all type of workloads like Linux, Red Hat, Ubuntu, Windows Server, or ESXi. But there are different levels of support, like the certification from the vendor is not always on OCP. So that's something to consider. But if you look at an example workload such as OpenStack, they already mentioned that they work on standard hardware. They use the same components as we use: compute, networking, and storage. So that's one of the workloads that it works like OCP, and OpenStack is kind of a perfect match. We also have other example workloads you can find on our website, for example, like running Kubernetes on OCP hardware. That's Wewin has written a nice PDF on how to do that. So that's also one of the workloads that's a perfect fit with the OCP gear that we offer. And you should, like I said, you should start to think rack scale. And what that would look like is that you would have certain types of rack configuration. This is an example that I took from a Facebook presentation where they say like this is their type 4. This is what they use, for example, for Hadoop. Or they have also a powerful compute version. Another type for database applications. You see the middle is empty actually, and I'll explain more about that later. So in terms of the building blocks that we use this OpenRack v2 designed by Facebook. This is the dimensions. It's a little bit bigger than probably your standard 19-inch rack that you have now, and it has 2 power zones. We offer this same rack with different power configurations. The picture in the middle is from our OCP Experience Center. We have the dual AC input configuration that is kind of what we offer to most data centers, because most co-location facilities or smaller data centers, they'll have this A and B power setup, which is quite different than what the hyperscalers use. So we try to match this with what the customer already has in their data center. So even for telco, we have that 48-volt power shelf as well. The power shelf has a management card that is inside of the power shelf, so you can manage and monitor it from remote. We also have an option with battery backup system. So there's actually lithium-ion batteries inside the rack. Helps you save a little bit on that conversion instead of going through your like room UPS. The power shelf converts to 12 volt. That feeds into the bus bar, and then the bus bar charges the batteries. And when the mains fail, that battery shelf will provide power to the bus bar. And we have one vendor that has this available, and we've delivered this to a customer. In terms of server, we try to promote the Tioga Pass design. The CPU is the Intel Scalable family. It's a 2U 3-node, sits inside a cubby. And it has some storage on board. It uses 12 volt, obviously, like all the other stuff that we do is all based on 12 volt. What you would do is typically you would have, like I said, the minimum amount of components. So you have sort of like 2 different type of servers, like a low and a high. These are examples of what a low and high server would look like in terms of specifications, but you try to keep your configurations as simple as possible. On the storage side, we also have several options, such as 12G SAS or a full NVMe, or the one in the middle, which is can be converted into different storage configurations, like one to be an external JBOD or to be a storage server with a micro server inside of it. So it's all flexible, but it's based on these 3 storage components and then configured in a way that fits your application. Networking, there's no like single answer, but you have to consider when you design your network, especially when you want to use open networking, you choose like a silicon, a manufacturer of the silicon, that the silicon provides the basic functions, and there's choice like Broadcom, Mellanox, there are different vendors that make the KVM. They all make chips that offer different features. And then you have to make a choice of manufacturing, such as EdgeCore or Mellanox as well, or another manufacturer that makes actually the box around the chip. And then you choose your operating system. Do you need a lot of features or you need very few? Telco might be different than a data center. So those are specifics that really have to think about before you start deploying this. You can go for a single top of rack switch if you can handle like a complete failure of the rack in case the switch breaks. But you could also go for a dual top of rack, having a dual NIC card. Then when you upgrade a switch or when a switch fails, you don't lose that whole rack. So that's something you have to consider about your failure domain. Then there are very few switches. It's only the edge core wedge actually that can connect to the 12-volt bus bar. So if you're using that lithium battery backup inside the rack, then you want to have your switch also still running when the mains fail. So there's another consideration that you have to make, like how am I going to power my switch? We can do that with the edge core wedge. Typically, this would be the network design for your data center. And this is a picture from Cumulus Networks, because that's a very well-known operating system for inside the kind of a non-hyperscale network. We do also make calculations of the rack because we are limited in, first of all, the space that it has to go in. And also the power that can be drawn, like how much does the data center actually offer us, and how much cooling do they offer. Normally, when you go into a colo, you might not even think about this, or you know that you're getting 5 kilowatt from them, but in this case, with OCP, it can easily grow to 12 kilowatt per rack. There's also the weight, so we make also a weight calculation. And that's also something to consider, because you don't want your rack to like fall through the raised floor of a data center. So that's some calculation you have to make before you bring the stuff into your data center. So if you want to verify by yourself if your facility is able to accept OpenRec v2, then we've worked with the data center group of OCP on the facility guidelines. And from there, you'll be able to check if your facility is matching that. For example, we prefer all cables to be from the top of the rack, and dimensions, etc. is all mentioned in this document also for different OCP deployments. So also the Project Olympus, for example, it's also mentioned in that document. Basically, we can deliver anywhere in the world. So if you have a global operation, we work with partners that have assembling locations, for example, in China, Mexico, and the Czech Republic for global delivery of like the same configuration delivered anywhere in the world. And actually, that is not relying on any shipping like through the US. So I just wanted to mention that there's no added tariffs or risk of that. Oh, I'm going too fast. So recently we've added a lot of products to the OCP Marketplace. For example, there was no open rack on the Marketplace, and we've recently added all the different rack designs. So the open rack v2 without power shelf and the 3 configurations that we offer, they're all on the Marketplace. So you can just go there, look for stuff that is either accepted or inspired. The racks, for example, are expired at the moment because inspired at the moment because not all the designs have been uploaded, but it is the exact same rack that the hyperscalers use. So because we are a solution provider, we're able to add components to the Marketplace. If there's anything missing or you'd like to know more about something on the Marketplace, just let me know. And then the OCP Foundation asked me to show some more pictures. I think you might have seen this in another presentation from our customer, but this is one of the completely assembled racks that we delivered as a proof of concept to a telco customer. And so we assembled the whole rack, including those blank panels, cables, whatever. And then another solution that we provided was on the stage yesterday, and now it's at our booth. It's the based on the MyTechESA. MyTech designed this subassembly to be able to use OCP server slats in a 19-inch rack. What we did is we added the switch and we added the cabling. We offered remote access to Red Hat for installing this remotely, and then we delivered it completely in a box, completely assembled, just plug and play ready. We delivered it here behind the stage. So Circle B is here to help. You can reach out or find more information on any of these pages, links. And this was my presentation.
Thank you, Menno. Do we have questions in the audience? Questions about the presentation, the different gears, deployment?
Any other solution providers here? Okay.
Since we don't have questions from the audience, I'll ask a few then. So what's the strangest configuration you've been asked to provide? Anything unique, odd?
Well, that's the challenge, because everyone wants to have something unique, but sometimes it's just like a big chunk of metal, basically, that like the rack is welded, and then when we have to deliver this into a space that even a person cannot stand up, then that's challenging. But we're, as a solution provider, we try to get ready components that are like fully supported, like CE certified, all those things that you need to get something into Europe and that we need to support it. So we try to get everything. We try to make a solution out of stuff that already exists, that have user manuals, firmware updates, and stuff. So those are challenges. But we don't make anything ourselves. So that's really that's the biggest challenge, I think, for everyone who wants to have a solution based on OCP, is like, which components am I going to use?
Are there any components that are missing that you think the community needs to work on, or components that customers are asking for modifications for that we should be aware of?
So I think the ESA is quite interesting, because it would help us to get stuff into places where there's no OCP now, and there's also no capability to use that, like the big racks, but there's only, for the cubby, there's only servers, and it would be nice to have, for example, NVMe storage inside of a cubby space, because now that's all 21-inch wide.
As you just said, it is all 21-inch wide, but earlier you made references to Project Olympus as well, which is based on 19-inch rack. So
Yeah.
the question is, how do you compare the two? How easy one was compared to the other? Earlier there was a question about maybe even power efficiencies and others. Have you compared them both?
It's difficult to compare with Project Olympus. It's specifically made for Microsoft, and it also requires you to use like the whole rack. Then, as far as I know, there's still stuff that is missing. It has a special PDU, special firmware, but maybe I'm not the right person to answer that question. But it's not so easy to adopt Project Olympus, especially at a smaller scale.
You probably have seen that people have. We were here as a part of open source hardware community.
Yeah.
And based on Project Olympus, people have recognized that, and they have created power adapter modules that bolts onto the back of the server and provide a C13, C14 cables.
Yeah, I have one of those.
Yeah. Okay. So any other things that people do?
that people do. Sorry.
What other things have you seen from Open Compute projects that helped others build an adapter to fix a problem that they have seen?
Like stuff that other people made for OCP. There are, for example, we have worked with a company that made these toolless rails, which I thought was very nice because it's those, like when you're building the rack into a specific configuration for a different customer, then it's nice to have those like toolless designs. So that's also been submitted. It's OCP accepted, and we added it to the marketplace, the toolless rail kit. And also the filler panels in metal, because some the hyperscalers, they use these cardboard boxes, but no, like when people see that, like this is not getting into my data center, so there's also the filler panel that's been added. What would have been nice, what would be nice, is to have also more like software on the software side and firmware collaboration and software, like management tools. Those stuff is what we still are lacking. Like we are promoting the 21-inch open rack because there is already on the hardware side there's a lot of choice. We have different vendors making server modules that fit into the same cubby space, but we're still looking for example, like how do I manage all of them and while they look the same from the software perspective.
Thank you.
I could actually speak to some of that. We're actually looking at that in the storage group. You mentioned about how we manage the storage. You also made mention to looking for NVMe devices. Do you get requests on specific form factors, capacity, or technology? Do people come to you with a problem statement, or do they come with a solution that they want something, and how do you integrate that into a rack?
Yeah, we usually ask them for functional requirement, and then we offer like what is available. Like I said, it also has to be something that's in production, and you don't want to wait for a year to get it, and you don't want to be the one paying for certification or something. So it's also, that's what we take into consideration.
Excellent. And for those who aren't aware, in the storage track, we're actually looking at a lot of these use cases, specifically how do you manage storage devices, NVMe form factors, whether that's M.2, U.2, EDSF-long or short. We're looking at the manageability of these items. A lot of NVMe over Fabric conversations are happening, so the community starts to evolve on specific technology interfaces, but there are many different software layers on top of that, many different management stacks, so we'll try to work as a community to narrow that down, to hopefully help the adoption story, make it a little bit easier. Any other questions?
Comments?
All right, if not, thank you very much, Menno. Appreciate it.
Thank you.